dope as me. I graph so fast, so clean. Can't nobody fact like me. I graph so fast, so clean. 8 for graphing rational functions. So difficult. Graph so fast, so clean. Alright. Here we are in 8-4. Such a lovely time we will have here. Such a lovely time. Here in this section, we're going to graph rational functions with vertical and horizontal asymptotes. And then we're also going to graph some rational functions with oblique asymptotes and points of discontinuity. Well, I hate to ruin your day, but we're actually not going to be graphing anything with oblique asymptotes. So we're just going to find points of discontinuity. So let's get into our vocabulary here. Anytime you have a rational function, that is an equation where you have a function on top divided with a function on the bottom. So in the previous section we had a reciprocal function, which meant we just had a number on top and a function on the bottom. This time now we're going to be doing a function divided by a function. So what we have to do is you're going to have to find some zeros, some vertical asymptotes, and horizontal asymptotes. So in order to find a zero of your function, and that is where your graph crosses your x-axis, you're going to have to set the numerator equal to 0, and then you'll solve that. And then when you find a vertical asymptote, which we actually did in the previous section, when you have to find a vertical asymptote, what you have to do here is you have to set your denominator equal to 0. So we've already done that part. Now the new part is, besides the 0, is we're going to have to figure out how to find a horizontal asymptote. And we have a little table down below. And when you find a horizontal asymptote, you actually have 3 different options. So because you have a function in the numerator and a function in the denominator, n is just going to be your numerator, n is going to be your denominator, denom. And what we're going to do is we're going to look at the degree for each of these. So if your degree of your numerator is less than the degree of your denominator, then your horizontal asymptote is always going to be a y equals 1. So, for example, we're missing a2 here. This should be x squared. Aha. So in this case, notice that your degree of your numerator is less than the degree of your denominator, which means if that's 1, that's less than 2, your horizontal asymptote is going to end up being y equals 0. Now, if your degree of your numerator is greater than your degree of your denominator, you do not have a horizontal asymptote. In fact, notice this little asterisk here. If your degree of your numerator is greater than your denominator, then you have no horizontal asymptote, which means there could be an oblique asymptote or a point of discontinuity, which is what we're going to be learning about. So if you look at the example here, you have a x to the third on top and an x to the first on bottom. That means you have no horizontal asymptotes. So, or you could just say HA. Now, my favorite is when the degree of your numerator is equal to the degree of your denominator. And in that case, what you're going to do is take the coefficient, or sorry, you have to take the leading coefficient on top. Your leading coefficient is the coefficient in front of your highest degree. And what you're going to do is you're going to take that leading coefficient and you're going to divide it by your leading coefficient of your denominator. So for example, what we have is, oops, I can't even spell right. What we have here is we have a y equals x over 2x plus 3. So your degree here is a 1, degree here is a 1. So in order to, since those are the same, in order to find your horizontal asymptote, you're going to take your coefficient on the top, which is a 1, and we're going to divide that by a 2. So your horizontal asymptote is a 1/2, or you guys might call it 1/2.